In this problem, I'm trying to get letter B by itself, so I can write the equation down and try to get this one right here, this letter B, isolated. So to try to do that, I got to move everything else over. In order to do that, I know that B is first being multiplied by negative 3a and then added by 6c. So in order to go into reverse order, I need to first subtract the 6c from both sides. When I do that, I get to cancel these. And I have negative 3ab literally equals d minus 6c. Now to get this b by itself over here, I see that it's being multiplied, these invisible multiplication signs, by a and negative 3. So in order to undo that, I got to do the opposite, which is division, by both negative 3 and a. Negative 3 and a. And I get to cancel negative 3 and a on this side, reaching my goal of getting b by itself. Again, literally, b equals d minus 6c over negative 3a. This right here is my final answer. Right here, I have a problem with fractions, so I know automatically I want to clear my fraction. I have all these denominators, and I'm looking for the LCD. I'm looking for what that is. However, my advice to you is when you see something like this with the distributive property, you do that first. All right, so let's distribute this 4 to 1/4 x and 2. When I do that, 4 times 1/4 is just 1x, and 4 times 2 is positive 8. I'm going to bring down everything else on both sides. 3 over 4x plus 1/2 x minus 5. Drop down the equal sign as well as this minus 3. All right, so I still have fractions, so I still want to use this LCD to clear it. D right here stands for denominator, so I look at 4 and 2. What is the smallest number that 4 and 2 go into? It's going to be 4. Now, the LCD, what I do with that is I take everything here and multiply it by 4. So that's 1, 2, 3, 4, 5, 6 things that I'm multiplying by 4. Actually, you know what, before we do that, let's combine some like terms. So I can combine this 8 and this minus 3. So 1x and then 8 minus 3 is negative 5. On this side, just one more time, bring down what I haven't solved yet. All right, now I'm ready to multiply by 4. So I'm going to multiply this term, this term, this term, this term. So a total of 5 things that I'm multiplying by 4. All right, so when I do that, the trick is I can figure out how many times this denominator goes into here. So 4 divided by 4 is 1. So this one can just stay 3 times 1, 3x. Over here, 2 goes into 4 twice. 4 divided by 2 is 2. So I can multiply this top number by 2. Becomes 2x. And then negative 5 times 4 is negative 20. On this side, 1x times 4 is pretty simple, 4x, and negative 5 times 4 is negative 20. Now I can start to combine some stuff. I have 3x plus 2x, which is 5x, minus 20, and on this side, I have 4x minus 20. Okay, let's move the fraction over. Sorry, move the variable over. These end up canceling, and I get 1x minus 20 equals negative 20. Now, a lot of you guys would be confused here, but there's an answer. This is the one solution problem. To get this x by itself, I'm going to add 20 to both sides, leaving 1x equals negative 20 plus 20, 0. And this has a solution because I can divide both sides by 1, and x ends up equaling 0. That's going to be your final answer. So this is going to be probably one of the more complicated fraction problems that you see. I have all these fractions, and I also have distributive property. So I don't like fractions, so I know I'm going to clear it by finding the LCD. My advice to you is to distribute actually this 4 before you try to clear the fraction. So if I distribute this 4, I can go from there. So 4 times 1/4 is 1x, and then 4 times 2 is positive 8. I'm going to drop down everything on both sides. So I have 3 over 4x, 1/2 x, and a -5. I also have a -3 on this side. Now, before I do anything with clearing the fractions, I see that this +8 and this -3 are like terms, so why don't I go ahead and combine them? This becomes +5. Make sure you keep the correct signs. And I'm going to drop down everything else. When I do that, now at this point, I have some nice easy numbers with some fractions. I'm going to use my LCD now. So this letter D stands for denominator. So I'm going to look at my denominators, which are 4 and 2, and figure out what is the smallest number 2 and 4 both go into. That number is going to be 4. 4 goes into 4, and 2 goes into 4. So I'm going to take everything here. I have 1, 2, 3, 4, 5 things, and multiply it by 4. 4 right here is the same thing as 4 over 1 technically. So this 4 is getting multiplied in the numerator. So let's take everything. 1, 2, 3, 4, 5 things, and multiply it by 4. All right, the shortcut here is I can figure out 4 divided by 4 is 1. So I can just take 3 multiplied by 1, and this is left over with 3x. Right here, 4 divided by 2 is 2. So I can multiply the top number by 2. That leaves 2x. And right here, I have 4 times -5. So that's -20. On this side, I have 4 times 1x, it's 4x, and 4 times +5, which is +20. Now the signs are important, so make sure you don't mess those up. Let's combine some like terms. 3 plus 2x is 5x. Bring down -20, 4x, and 20. Let's move this 4x over to keep it positive. Now I have 1x minus 20 equals 20 when I cancel those out. My final step to get this x by itself is to add 20. And cancel 20 plus 20 is 40. And I bring down this 1x. 1x or x equals 40 is my final answer. In this problem, I'm looking to get t by itself. So I'm looking to get this variable all the way isolated. So I'm going to ask, what is happening to t? T is first being multiplied by x, then divided by r. After that, it's being subtracted by 2q. So I need to go in reverse order, or in inverse order. When I do that, I do what happens last first. So the first thing that I do is add 2q to both sides. When I do that, these cancel, leaving c plus 2q, and on this side I have x t over r. Now t is being multiplied by x and then divided by r, so I need to go in inverse order. I'm going to take this divided by r and do the inverse, which is multiplication by letter r. I get to cancel these r's, leaving x t, and on this side I have r parentheses c plus 2q. My final step to get t by itself is to do the opposite of times x, which is divide by x. My final answer when I cancel these out is t equals r parentheses c plus 2q all over x. Again, with a literal equation, I'm going to go in inverse order. So right now I'm trying to get x by itself. This is the letter I want to isolate. So I need to figure out x is being multiplied by 1/3, and it's also being multiplied by r cubed. Let's deal with this fraction last because it's more complicated. In order to inverse times r to the third, I'm going to divide by r to the third. When I do that, these cancel, and I'm left with v divided by r to the third equals 1/3 x. Now this looks complicated, but it's really not. I still have multiplication, and in order to inverse times 1/3, I'm gonna divide by 1/3. If you guys remember, dividing by a fraction is the same thing as multiplying by its reciprocal. What that means is I take 1/3 and I flip the numbers. So dividing by 1/3 is the same as multiplying by 3/1, or just 3. So in order to cancel 1/3, I'm gonna multiply both sides by the reciprocal, 3. This 1/3 cancels the 3, and I'm left with just x, which is the goal. Remember that multiplying by 3 is the same thing as 3/1, and I multiply fractions straight across. So on the top, I have 3 times v, that becomes 3v, and on the bottom, 1 times r to the third is just r to the third. So my final answer for x is 3v divided by r to the third. All right, again, I see some fractions that I don't like, so I'm going to try to clear them. In order to do that, I'm going to find the least common denominator. I have 4 here and 4 here as my denominators, and I know that the smallest number that both of these go into is 4. I'm going to take every term, 1, 2, 3, 4 different terms, and multiply it by the LCD. So times 4, times 4, times 4, and times 4. The trick here is that 4 divided by 4 is 1, so I can just keep my numerator, multiply it by 1, which still leaves it as 5, and drop the variable p. Right here, 4 times 3 is 12, and I drop the p. Right here, these 4's, 4 divided by 4, also cancel. It's just 1, so 21 times 1 is just 1p. And over here, 21 times 1 is 21. And right here, negative p times 4 is negative 4p. This is much easier to solve than with the fractions, and I'm ready to go. So let's move the variables onto one side. Let's first combine like terms. So I have 5p plus 12p, and I get 17p. On this side, I have 21p minus 4p, and that's actually also 17p. So what do we notice about this? 17p equals 17p. Well, they're the same on both sides. And what do we know about equations that are the same? Well, we know they are true statements, which means that if 17p is on this side and 17p on this side is on this side, p could be anything. And if p can be anything, we call this infinite solutions. So infinite solutions is your final answer. All right, so this was a huge problem that students got wrong on the test. I have a fraction and a fraction. You guys are really confused that this numerator had multiple terms, but you're still gonna clear it. This is still a clearing fractions problem. So let me just rewrite it. All right, so I can still get rid of this 4 and get rid of this 3 by finding the least common denominator. I have 4 and 3. The smallest number that 4 and 3 go into is 12. So what I'm gonna do, just like before, I'm gonna take all of these things and multiply it by 12. Guys, remember that 12 is the same thing as 12 over 1. So it's technically all over 1. So 12 is being multiplied by the numerator, not the denominator, but the numerator. When I have multiple terms like this, it's like saying 12 and then distributing it to negative 3x and negative 6. So when I distribute it in the numerator, I get 12 times negative 3x, which is negative 36x, and 12 times negative 6, which is negative 72. And this is all over 4. Don't forget that. Over here, I have 12 times 5, which is 60. And I have 12x on the numerator, and this is all over 3. And there's a positive sign, a plus sign in between. When I do this, I can cancel the fraction because all of these numbers are now divisible by the denominator. Negative 36x divided by 4 is negative 9x. Negative 72 divided by 4 is going to be negative 18. And on this side, I have 60 in the front, and 12 divided by 3 is going to be 4 with the x carrying down. This I can solve. Let's try to move the variables on one side. I'm going to add this 9x to keep it positive. These cancel, leaving negative 18 and 60. And when I have 4x plus 9x, that equals positive 13x. I'm going to subtract 60. Cancel this. Negative 18 minus 60 is going to be negative 78. And this is all equal to 13x. When I take negative 78 and I divide it by 13, make sure you keep your signs when I do that. My 13s are going to cancel, getting x by itself finally, and all of this, a positive divided by a negative, a negative divided by a positive is going to be a negative, and that value is going to be 6. All right, so when I read this, I have 3 consecutive odd integers. Odd integers is really key here. So I have 3 numbers. Let me make a table of 3 numbers, and odd integers means that I'm going from x plus 2, and then x plus 4. Now I'm ready to read the rest of it. So it's such that the sum, I know the sum is addition, so I'm adding something, 4 times the second number. This is the second number. This is the first number, this is the second number, and this is the third number. So if this is my second number, and it's 4 times this, I can't just have 4 times this. I gotta put this in parentheses. So I have 4 times the second number. And then it says the sum of that and twice is 2, the third number. So that's x plus 4. The key word right here is is. Is means equals. That's really, really important. Is means equals. So all of this is equal to 6 less than. 6 less than is either 6 minus or it's minus 6. This is a common mistake. 6 less than means minus 6. So with 6 less than, there's a minus 6 involved, then 8 times the first. If this is the first number, I do 8 times the first, and it's 6 less than. This right here is my equation that I'm setting up. I'm going to rewrite it down here just so I have some extra room. All right, and now I'm ready to solve. So I distribute this 4x plus 8 is added to 2x when I distribute it plus 8. Over here, I have 8x minus 6. I can combine some like terms. 2x, 4x is 6x, and then 8 and 8 is 16. On this side, I have an 8x minus 6. Let's move the 6x over to keep things positive. These cancel, leaving 16 equals 8 minus 6, 2x minus 6. I'll add 6 to both sides, cancel, 16 plus 6 is 22 equals 2x. When I divide by 2 on both sides, my final answer is going to be x equals 22 divided by 2 is 11. My final step is to go all the way back to my table. If x is 11, the next consecutive odd number, so just like it said, consecutive odd number is going to be 13, and the one after that is going to be 15. Right here is my final answer. The easiest thing for me to do when I have a shape like a rectangle is to visualize the problem. So I'm always going to start by drawing a rectangle. The width is 1/4 its length. The biggest problem on the test is that you guys weren't really sure what 1/4 its length meant in terms of math. That means that the width right here is 1/4 times L, or just 1/4 L. That leaves the other sides as just the length represented by the variable L. Right here it says the perimeter is 300. That means I'm taking all 4 sides and I am adding them. So I'll have L plus 1/4 L plus 1/4 L equals 300. When I have that, all 4 of these are like terms. I can just add them together or combine them. The number in front of L is 1. So when I combine 1, 1, 1/4, and 1/4, 1 plus 1 is 2. And 1/4 plus 1/4 is 2/4, which is 1/2 or 0.5. I drop down the the variable, which is L, and that all adds up to equal 300. My final step to get L by itself is to divide by 2.5. These cancel, leaving L, and when I do 300 divided by 2.5, I'm just going to use 25 for now and then move the decimal later, I'll get 12. But since the decimal is actually here, I'm going to add another spot, and my answer is 120. So if L is 120, I solve part of it, which is asking for the length, but I have to go back and find the width as well. So what is 1/4 L, or what is 1/4 of 120? This is the same thing as dividing by 4. So when I multiply these straight across, this becomes 120. Or sorry. If I divide this by 4, it becomes 120 divided by 4. So my width is 30. So my length is 120, and my width is going to be 30. All right, so I have a triangle, and I know that triangles add up to equal 180. So I have 1, 2, 3 angles. Please do not forget about this one. This is still an angle right here. Although it has no variables, I know that this right angle is 90 degrees. So let's add all of these up, and it equals 180. So I'll do 2x plus 25 plus 90, and then minus 3x plus 71 all adds up to equal 180. Let's combine some like terms. So I'll do 20 plus 90 plus 71. And when I do 25 plus 90 plus 71, I'm going to get 186. When I do 2x minus 3x, I'm going to get negative 1x. And on the opposite side, I'm going to bring down 180. To get this x by itself, I'm going to subtract 186 from both sides. These cancel, leaving negative 1x, and 180 minus 186 is negative 6. To get the x by itself, let's just divide by negative 1, canceling out the negatives. X equals negative 6 divided by negative 1, which is positive 6. So I have x, which is great. Go back and read the question, solve for the measurement of each angle. So right here, one of the angles is 90. So this is one of my final answers. When I plug 6 back in over here, I can do negative 3, and I plug x in, which is 6, plus 71. When I do that, I'll have negative 3 times 6, which is negative 18 plus 71. When I do that out, I'm going to have 53 as this angle right here. Now, let's do this one. I'm going to plug in this value of 6. 2 times 6 plus 25. I'll get 12 plus 25, and when I add 12 plus 25, I get 37. So my three angles are 90, 37, and 53. All right, in this problem, I'm dealing with two different students and two different time periods, so I'm going to make a chart. I have two different students, so I can do student 1 and student 2. I have two different time periods. One is going to be the present, and the other one is 4 years ago. So it's my present subtracted by 4. So let's go and fill in the information that we know. The sum of the ages of the two students is 16 years, but we don't know anything about that yet, so let's keep on going. 4 years ago, so I'm in this column, 4 years ago, the age of the older student was 3 times the age of the younger student. So it doesn't matter which one is which, but one of them was 3 times the age of the younger student. So that's 3x, making the younger student just x. Now, if the present was 4 years ago, if this was 4 years ago, the present is 4 years in the future. So I need to add 4. I have 3x, and if this was 4 years ago, 4 years in the future is adding 4 to it. And if this is 4 years ago, again, the present is going to be adding 4. This one's just x, sorry. So I can go back and read the problem. It says the sum of the ages of the two students right here in the present is 16 years old. Sum means addition. So I'm going to add student 1 in the present, 3x plus 4, and then student 2 in the present, because the sum of their ages is 16. Now I'm going to solve. When I combine like terms on the left side, I have 3x plus x, which is 4x, and then 4 plus 4 is 8. To get the x by itself, subtract 8 on both sides, and now I have 4x equals 8. When I get x by itself, I'll divide by 4, and my x value is going to be 2. So let's go back into our table and plug it in, see if that makes sense. What is 3 times 2 plus 4? Well, 3 times 2 is 6, plus 4 is 10. So in the present, student 1 is 10. If x is 2, 2 plus 4 is 6. And let's just find 4 years in the past for the fun of it. 3 times 2 is 6. And x by itself is just 2. So let's see if this makes sense. The sum of the ages of the two students is 16. So in the present, is 10 plus 6 16? Yes, that's true. And then 4 years ago, so in this column, the age of the older student was 3 times the age of the younger student. Is this one 6? The same thing as 3 times the age of the younger? Is that true? Yes, it is. So I just double check that my work is correct. My final answer, find the present age of each student. The present age is going to be 10 years old and 6 years old. All right, so I'm dealing with two different people, Whitney and her daughter. So I have Whitney here and her daughter. I also have two time periods in 8 years. So one of my time periods is the present, and the other one is going to be the present plus 8, because it's 8 years in the future. All right, so right now Whitney's age is triple her daughter's age. So Whitney is triple, that's a 3, her daughter's age, but we don't know how old her daughter is, so I'm going to put an X. That makes her daughter the unknown variable, simply X. If I add 8 years in the future, I'm going to take 3X and X, just what they are, but I'm going to add 8 years because 8 years applies to both people. And now I have everything I need to move on. In 8 years, so in this column, the sum of their ages will be 72. Sum means addition. So I'm going to add Whitney and her daughter's age in 8 years. So I have right here 3X plus 8, and I'm going to add it to her daughter's age, which is 8 plus X. And it says the sum of it will be 72. So when I solve all of this, let's combine some terms. 3X plus X is 4X, and 8 plus 8 is 16. When I solve the rest of this, I'm going to subtract 16 from both sides, leaving 72 minus 16, and that's going to be 56. I drop down the 4X, and my final step is to divide by 4. When I divide 56 by 4, these cancel, and I get a total of X equals 14. It says, how old are they now? So this is this column. I'm just going to plug 14 in for what it is. So X is 14, her daughter is 14 years old, and then if Whitney is 3 times that, 3 times 14 is going to be 42. So Whitney is 42 and her daughter is 14. All right, so if there are 2 numbers, let's draw a table for just 2 numbers. I'm going to say number 1 and number 2. The larger number, we don't know which one it is, it's just larger, is 7 times bigger than the smaller number. So the smaller number is what I don't know. That's X. But the larger one is 7 times bigger than the smaller one, not one, so it's just 7 times X, or 7X. If the difference, we know that word difference means subtraction, the difference between the 2 numbers. So I'm going to subtract the bigger number by the smaller number. So it's going to be 7X is the bigger number minus the smaller number. That's what the word difference means, is 252. Now I can just solve. So 7X minus X is 6X, and that's equal to 252. When I divide this, 252 divided by 6, you guys can solve that out by yourself. That's going to give me X equals 42. So that's my X value. But it says, what is the largest number? If X is 42, I'm going to take 7X, so that's 7 times 42. My largest number is going to be 7 times 42, which is 294. So my small number is 42, and my large number is 294. You can double check that because the difference is 252. So if I were to subtract them, 294 minus 42 does in fact equal 252. That's a way to double check. In this problem, I'm dealing with 3 different people, so the easiest way for me to organize this is to make a table of 3 different people. I have Connie, Taylor, and Samantha. All right, so let's read this. Connie weighs 65 pounds less than. Be careful of this common mistake. 65 less than is either 65 minus or it's minus 65. It's this one right here. It's minus 65. So she's 65 less than twice Taylor's weight, and we don't know Taylor's weight. We can make Taylor X. So So 65 less than is going to be a minus 65, and it's less than twice Taylor's weight. So twice Taylor's weight is going to be 2x. Moving on, it says Samantha weighs 30 pounds more than Taylor. More than means we're adding 39, and more than Taylor, Taylor's x, that's what I put in front of it. The next sentence says, if Connie and Taylor, so Connie and Taylor are the same weight, how much does each girl weigh? I'm sorry, so I realized a mistake. I'll correct this on your worksheet. We're gonna change that to if Connie and Samantha are the same weight, how much does each girl weigh? So I corrected that on your worksheet. So the key word here is the same. The same means equal. So I'm gonna take Connie, who is 2x minus 65. The same means equal to. That's key, it means equal to. So Connie and Samantha are the same. I'm gonna drop Samantha down on the other side of the equal sign. When I solve for this, I'm gonna move the x's to the same side. These cancel, and I have 2x minus x, which is 1x, minus 65 equals 39. I'm gonna move the 65 over by adding it. And this leaves 1x, because the 65's cancel, equals 39 plus 65. That's gonna be 104. So x equals 104. I'm gonna go back and plug that in for the center column. Taylor's 104 pounds. Now it says, how much does each girl weigh? I'm just gonna plug them in to each of these equations. So Connie becomes 2 times 104 minus 65, and Samantha becomes 104 plus 39. When I end up solving this, this becomes 208 minus 65. And when I do that out, 208 minus 65 is going to be 143 as Connie's final weight. And Samantha's 104 plus 39 is going to end up to also be 143, which makes sense because the problem says that Connie and Samantha are the same weight. So these three right here are your final answers. Okay, with scientific notation, I have some normal numbers here, and then I have numbers with exponents. So I'm going to do just my normal numbers first. I have 4 divided by 5. Now, if I don't know what this is in a decimal, I can use this trick where 4 divided by 5 is the same thing as 8 divided by 10. That's much easier to convert to a decimal, and we know that 8 divided by 10 is equivalent to 0.8, or literally 8 tenths. So I dealt with my normal numbers, now I can do the ones with the exponents. 2 ways I can do this. First way, I have 10 to the power of negative 12. All right, so when I have this problem with scientific notation, I have some normal numbers and I also have numbers with exponents. So let's deal with the normal numbers first. I have 4 divided by 5, and I'm going to convert that into a decimal for scientific notation. If this is confusing, I can always convert it to a number that's more decimal friendly. So 8 over 10 is equivalent, and I know 8 over 10 is equivalent to the decimal 8 tenths, or 0.8. So that's going to be the beginning of my number. Now to deal with these numbers with the exponents, I have 10 to the power of negative 12 over 10 to the power of negative 7. 2 ways I can do this, and I think both ways have advantages and disadvantages. So this one over here, I have negative exponents. In order to make them positive, I can just move this one up and move this one down. This becomes 10 to the power of 7 over 10 to the power of 12. When I subtract, because it's division, it becomes 10 to the power of 7 minus 12, which is equivalent to 10 to the power of negative 5. Another way that you could do this is I could go back to what it is over here, and I could just subtract using these numbers. So I could do 10 to the power of negative 12 minus negative 7. When I do this, this becomes keep, change, flip, negative 12 plus 7, which is also going to equal, either way, 10 to the power of negative 5. So let's combine these. My beginning number is going to be 0.8. And then my exponent is going to be 10 to the power of negative 5. However, you want to rewrite it in scientific notation. And this is not in scientific notation because this number needs to be one digit, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And it's not. So I'm going to move it one position over to make it 8.0. Now this number got bigger by 1, so this number needs to get smaller by 1. That's how I'm going to keep it equivalent. So when I do that, I have times 10, and one number smaller than negative 5 is negative 6. So your final answer is going to be 8 times 10 to the power of negative 6.